Hi viewers, welcome to All Force e-learning and welcome back to class 8 physics, and the chapter we are discussing is sound. In the previous sessions we have discussed about how is sound produced, and also with the help of an activity we understand that any vibrating body produces sound, and also we understand that sound has energy and sound can travel through solids, liquids and gases. About all these things we have discussed in the previous sessions. And the next topic is, now in this session I am going to explain about the characteristics of the sound. Nothing but the loudness of the sound, the feebleness, amplitude, pitch and the frequency of the sounds. All these are nothing but the characteristics of the sound. Now in this session we shall discuss about these concepts. Okay. Sometimes people talk loudly and sometimes softly. Generally we can able to hear sometimes a loud sound and sometimes we can able to hear the soft sounds. For suppose if you strike the bench hard, you can able to hear a loud sound, whereas if you just tap the same bench you can able to hear a feeble sound. In our daily life, in our surroundings, if you listen, you can able to hear so many sounds around us. Some sounds are maybe loud sounds and some sounds are maybe feeble sounds, right? For example, beating the drums in the school assembly, you can able to hear a loud sound. And of course, the pledge taken by students in the same assembly was feeble. Now the thing is, why some sounds are loud and why some sounds are feeble? And also, is there any relation between the intensity of the sound and the vibrations made by the body? Yeah, let us find out these answers in this session. Now with the help of an activity, let us understand the relation between the intensity of sound produced by a body and the vibrations of the body. You can see, look at here, you can see a diagram on this board. You can see a table. Now to do this activity, the material required are a table, a metal scale, better you take 30 centimeter metal scale, or a hacksaw blade also, better you go for a 30 centimeter metal scale, and a heavy brick which acts like a weight. These three things are required to do this activity. Here our aim is to find out the relation between intensity of sound and the vibrations made by this body. Okay. To do this activity, I am going with these three things as I said now earlier. Now to do this, first I am placing a 30 centimeter scale. I am using this 30 centimeter scale. In the 30 centimeter scale, let's say 10 centimeter of the scale should be rest on this table. Over this 10 centimeter which is kept on this table, place a brick which acts like a weight on the 10 centimeter scale already, which is placed on this table. The arrangement should be like this, whereas the 20 centimeter is outside of the table. The 20 centimeter of the scale is outside of the table, nothing but in air. This is the arrangement. 10 centimeter or 5 centimeter, whatever it may be, it should be placed on this table, and over this 10 centimeter or 5 centimeter place a heavy brick which acts like a weight. It is the arrangement. Now the thing is, you vibrate this scale with less amount of the force. You apply less force at the one end of the scale. What happens? The thing is, if you apply less force at one end of the scale, the thing is the scale starts vibrations and simultaneously you can able to hear the sound also. The thing is, you observe the vibrations and listen to the sound carefully. when we apply less amount of the force. In the case of less amount of the force, we have applied less amount of the force on the scale. Now you carefully listen to the sound and also observe the vibrations made by this scale. Note down this number of vibrations and also listen to the sound. Second case, same arrangement, it is same like that. Apply a large force at this end of this scale. If you apply large amount of the force, what happens? Of course, it produces sound. Listen to the sound carefully and also observe the number of vibrations made by the scale here. Let's say you can see the table here. Force is small and force is large, and the number of vibrations and intensity of the sound. When you apply small amount of the force, let's say the scale made 10 vibrations. Let's say the intensity of sound is low. Intensity of sound is low. When you apply large amount of the force, let's say the number of vibrations made here is 20. And the sound you hear is, of course, it is high. It is like this. Children, the thing is, what is the position of the scale initially? Initially the scale is at rest position, right? Initially the scale is rest position along with the surface of the table. This position is called mean position. Mean position of the scale. As I said that the scale is at rest position along the surface of the table. The position of the scale is called mean position. Okay, we can look at here. When you apply small amount of the force, the scale sets into vibration. It is moving along the path A, B, C. It is like this. OA is the mean position. You can see here. OA is the mean position. Whereas OB and OC are the vibrations made by this scale. OB and OC are the vibrations made by this scale. This is in the case of a small force. If you observe this diagram carefully, as the scale is moving down and it is moving up and down. The scale is moving up and down here. Now we can say that the scale is maintaining to and fro motion. The to and fro motion of a body is called what? Vibration. We have studied in class 6. The to and fro motion of a body is said to be vibration. You can see here the scale OA is moving down and it is moving up. It is making to and fro motions. The to and fro motion of a body is called vibration. So the number of vibrations made in the first case, when you apply small amount of the force, that is the 10, and the sound here is low. And also the thing is, it is the, you can see this displacement. This is the maximum displacement made by this vibrating body. As I said that the scale is set into vibration. This is the maximum displacement made by this scale, and this is also maximum displacement made by this scale. This maximum displacement is called amplitude. The maximum displacement made by this vibrating body on either side. On either side it is moving up and down. On either side it has made maximum displacement. This length is called, this length you can see, this length is called amplitude, and also this length is also said to be amplitude. This is the maximum displacement made by this vibrating body. Children, in the case of less force, this is the amplitude. Now coming to the large force, when you apply large force, the thing is, the scale, this is the initial position of the scale. OA is the initial position of the scale, which we call mean position of the scale. Mean position. OA is the mean position. Now when you apply large amount of the force, what happens? It moves like this. It moves down, OC, and again it moves up. It is like this, and again it is, we can say that it is making a to and fro motion. So the to and fro motion of the body is called what? Vibration. So the scale sets into vibration, which we call now. Now look at the length here. This is the maximum displacement made by this scale on either side. This is the maximum displacement made by the scale on either side. This maximum displacement is called what? Amplitude. The maximum displacement made by this vibrating body on either side. So this maximum displacement is said to be amplitude. Compare this amplitude with this amplitude. In which case the amplitude is more? Of course, by looking at this diagram we can say very easily. In the case of large force, the amplitude is more when compared to the small force. So the thing is, in the case of large force, the vibrations are more. In the case of large force, the vibrations are more. And the amplitude is also high. The amplitude is also more. Amplitude. In the case of small force, this is the amplitude made by this vibrating body. The amplitude is less. Whereas in the case of large force, the amplitude made is more. Now, we can make the relationship between the intensity of sound and this amplitude. Right? That is only our aim. Intensity of sound, amplitude and vibrations. We made relation between these three things here. As the number of vibrations are less, the amplitude is less and the intensity of sound is low. You can see here. When the number of vibrations are less, the intensity of sound is less and amplitude is also less. Whereas the number of vibrations are more, intensity is more, intensity is high, amplitude is also more. So, from this activity, we understand that intensity of sound depends upon the number of vibrations and also it depends upon the amplitude. I hope you understand, children, this concept. With help of these things, we understand that vibrations made by the body, in this case, an intensity of sound and amplitude here. So the intensity of sound here depends upon the amplitude and also it depends upon the vibrations. We have relation between the intensity of sound and amplitude, children. Intensity of sound is directly proportional to the square of the amplitude. This is the relation between the intensity of sound and the amplitude. Okay, I hope you understand this concept. Next concept is identifying the pitch of sound. This pitch we can also call shrillness. Pitch or shrillness of the sound. With help of an activity, let us understand this concept. On what factors this pitch depends also we shall discuss in this concept. Now, to do this activity, the materials required are a table, a wooden table, two 30 centimeter long scales, nothing but metal scales, and a heavy brick. First, you fix the scale. That should be like that. 10 centimeter of the scale should be rest on the table, whereas remaining 20 centimeter of the scale should be in air. In such a way you arrange this scale and place a heavy brick on this 10 centimeter part which is there on this table. Second case, fix another scale. Place another scale which is of 25 centimeter. 25 centimeter of the scale should be there on the table and the remaining part of the scale keep it in the air. The arrangement should be like this. Okay, two scales we are placed here. Over these scales we have arranged here a long brick. Now the thing is, vibrate these two scales. Apply same amount of the force in these two cases simultaneously. Apply same amount of the force on these two scales simultaneously. What happens? What did you observe now? The thing is, you can able to hear the sound, and if you observe, these scales are set into vibration. Let's say the scale 1 which is of 20 centimeter which is of 20 centimeter outside this table made less number of vibrations when compared to this second scale. Whereas second scale made more number of vibrations. And the sound heard in this both cases, first case the sound here is less shrill, less shrill. Whereas second case, the sound here is more shrill. In the two cases, if you observe, in the scale 1, nothing but 20 centimeter part of the scale which is in air made less number of vibrations, and the sound here is less shrill. Whereas second scale, when you compare with this second scale, in the second scale, the number of vibrations made are more, and the sound here is more shrill. This shrillness of the sound is also called pitch of the sound. The thing is, children, the shrillness of the sound is also called as pitch of the sound here. Okay. And the number of vibrations, as I said here, the scale 1 has made less number of vibrations and scale 2 made a more number of vibrations. The number of vibrations made by the scale or the number of vibrations made by the body in 1 second is called frequency. This is another important characteristic. Frequency is nothing but number of vibrations made per second, which is known as a frequency. Now, from this activity, the number of vibrations made in scale 1 is less. Now we can say that frequency of this scale is less because the number of vibrations made here are less. Frequency is also less because frequency is nothing but number of vibrations made per second. The number of vibrations made by the body in 1 second is called frequency. In the case of first scale, number of vibrations are lesser when compared to the second scale. So I am saying that frequency is lesser in the case of this first scale. Okay, whereas the shrillness is also less. Shrillness is also less in the case of the first scale. So now we can say like this. The frequency is less in the case of the first scale and shrillness is also less in the case of the first scale. Now this shrillness or pitch depends upon what factor? Frequency. Shrillness or pitch depends upon this frequency. If frequency is high, nothing but the number of vibrations per second are more, then the frequency is high. If the frequency is high, then the pitch is high. The frequency is high in the case of what scale? In the case of this short length scale. In the case of the short length scale, the frequency is high. How can I say the frequency is high in the case of the short scale? Because in the case of the short scale, the number of vibrations are more per second. The number of vibrations are more per second in the case of the short scale. So I can say now the frequency is high in the case of this short scale. So the shrillness is more in the case of this short scale. From this activity we understand that if less number of vibrations means less frequency and the shrillness is also less. If more number of vibrations, frequency is high and the pitch is also high. Now we can make the relationship between the pitch of the sound and frequency. Frequency and pitch. Pitch depends upon this frequency or shrillness depends upon this frequency. So short bodies make more number of vibrations and their pitch is high. Long bodies in length, long bodies make less number of vibrations and the pitch is less when we apply force. So in the previous session we have discussed one concept. Generally in men the vocal cords are long. So the frequency is less and the pitch is less in the case of the men. We have discussed this. Because the men vocal cords, the vocal cords which are present in men are long and the vibrations made by these vocal cords are less. So frequency is less. So pitch is less. So pitch of the men is less when compared to the pitch of the women. In the case of the women, the vocal cords length are short. Vocal cords are short. The vibrations made by the vocal cords in the case of the woman are more, and the pitch is more, or shrillness is more. So generally we used to say that shrillness is more in the case of the women, whereas shrillness is less in the case of the men. Not only the men and women, in the case of the birds and the animals also. For example, the birds made high pitch sounds, whereas the lion make a low pitch sound. The roaring lion is nothing but a low pitch sound. The birds chirping is nothing but high pitch sound. I hope you understand this concept. In this concept, we have made the relationship between the frequency, the pitch, shrillness, right? I hope you understand. Let us move to the next concept. Okay, before going to move the next concept, let me give few definitions. Already we have discussed one more time. Frequency means the number of vibrations made per second, and the frequency is expressed in terms of hertz. Frequency is expressed in terms of hertz. Okay. Intensity of sound. Intensity of sound, or nothing but loudness of the sound, is expressed in decibel. These are the units, these are the things. Frequency is expressed in the terms of hertz. Intensity of sound is expressed in decibels. Okay. Next concept is audible sounds. Audible range. First of all, what is this audible sound? Let us understand what is the audible sound. The sound which can be heard by the human beings are called as audible sounds, whereas the sounds which cannot be heard by the human beings comes under inaudible sounds. Two types: audible sounds and inaudible sounds. Audible sounds means the sound which can be heard by the human beings comes under audible sounds. The sounds which cannot be heard by the human beings are known as inaudible sounds. In the case of audible sounds, audible sound range is 20 Hz to 20,000 Hz. As I said just now, Hz is the unit for what? Frequency. So what is the meaning of this 20 Hz? A body makes 20 vibrations in 1 second. If a body makes 20 vibrations in 1 second, then the sound produced by the body can be heard by the person, can be heard by the human beings. So the frequency should be minimum 20 Hz and the frequency should be maximum 20,000 Hz. If the range, if the frequency is between 20 Hz to 20,000 Hz, then only the normal human beings can able to hear the sounds. One more time children, I'll explain. What is the meaning of 20 Hz? We are applying force on a body. That body is sets into vibration and the body is making vibrations, 20 vibrations in 1 second. If a body makes 20 vibrations in 1 second, the body produces sound. Of course, we know that any vibrating body produces sound. Here also the body sets into vibration, right? So we can able to hear this sound, children. If a body makes 20 vibrations in 1 second, that sound can be heard by the normal human being. This is the minimum frequency, minimum sound we can say. Minimum frequency we can say. Whereas the maximum frequency is 20,000 Hz. If a body makes maximum 20,000 vibrations in 1 second, that sound also can be heard by the human being. So a normal human being can able to hear this sound if the frequency is between 20 hertz to 20,000 hertz. Just now, as I said about inaudible sounds also. No? Whereas in the case of inaudible sounds, I think you can come to know what is inaudible sound now here. If the frequency is less than 20 hertz, if the frequency is less than 20 hertz, comes under inaudible sound. If the frequency is greater than 20,000 hertz, frequency is less than 20 hertz or greater than 20 hertz, these two things comes under inaudible sound. Inaudible sounds. If the frequency is less than 20 hertz and it is greater than 20,000 hertz, means these sounds comes under inaudible sounds. So a normal human being sound range is 20 hertz to 20,000 hertz. I hope you understand this concept. Let us move to the next concept. Noise and music. Noise. Yeah. The sounds which are unpleasant to hear are called as noise. The sound which is pleasant, which is very pleasant to hear for us, is known as music. Generally, in the case of noise, there are mixture of some irregular sounds. This noise is nothing but it is a mixture of some irregular sounds which leads to a noise pollution, which is unpleasant to hear this noise. Whereas in the case of this music, it is very pleasant to hear. We can relax with this sound which is pleasant to hear. In this case, it is a mixture of some regular tones. It is a mixture of regular sounds. It is a mixture of regular sounds. Music. Examples of this noise, you know very well. Traffic. Traffic comes under the example of this noise. Whereas industries, the sound made by the industries, factories, the sounds made by the washing machine at your home, the sound made by the mixer at your home, all these sounds comes under this noise. If you observe, in all the cases, there is a mixture of some irregular sounds which leads to a noise pollution. Whereas in the case of the music, examples in the case of the music, the sound produced by the musical instruments. About the musical instruments we have discussed in the first session, sound chapter's first session about the musical instruments. The sound produced by the musical instruments is called music. I hope you understand about this noise and this music. Okay. The thing is about noise pollution. Let me say about a few words. The pollution like air and water, noise pollution also happening these days, which is harmful to human beings. Generally, the loudness of the sound is expressed in decibels. I already said. The normal conversation between two persons, the sound loudness is 60 decibel. Normal conversation sound loudness is 60 decibel. If sound exceeds more than 80 decibel, it comes under noise pollution. So generally the sound produced by traffic, industries and factories, all the sounds produced here are more than 80 decibels. So that's why it comes under the noise pollution. I hope you understand, children, this. Now let us discuss about the harmful effects to human beings. Sound pollution, which is harmful effect to human beings. harmful effects or effects of sound pollution also we can say. The sound pollution affects to human beings like this: lack of sleeplessness, it leads to hypertension, it leads to increase in BP, blood pressure. All these things it takes place. If a person exposed to high sound, these things may happen which are harmful to human beings: hypertension, lack of sleeplessness, increase of this blood pressure. All these things happens. Now what we need to do, to control this noise pollution? Of course we cannot stop this noise, but we can control this noise pollution. What precautions we need to take to control this noise pollution? The thing is, attach silencers to the vehicles so that noise can be reduced. Make the machines that work with less noise. Manufacture the machines that should work with less noise. Plant the trees in your surroundings. Plant the trees along the road, along the sides of the road. Okay. And listen to the music in a very low volume. If you take these precautions, then you may not expose it to these health problems. I hope you understand these concepts. With this, the chapter finished.